Hi everyone, thank you for joining us for today's technical talk session. In today's session, we are going to talk about the BDK CLI and how you can make use of the BDK CLI tool. My name is Peter, and I'm a contributor to the BDK CLI tool. In today's session, I'm going to introduce you to the BDK CLI tool. I will talk about the current features of the BDK CLI tool, and then we'll do a live demo session of how to use the tool. So the Bitcoin Dev Kit develops and maintains a suite of libraries and tools to help you to build descriptor-based wallet applications. Some of the core libraries include the BDK wallet, which exposes the main wallet API. We have the BDK chain, which defines structures for storing and indexing chain data. You have the BDK core, which contains structures that are used by the BDK chain, wallet, and the chain crate. For a complete list of all the libraries available, you can visit Bitcoin Dev Kit on GitHub. You can visit the page to be able to see the current libraries, and then you can be able to, and then a corresponding link to each of the libraries so that you can be able to take a look at the code base. One among the tools that is being built and maintained by the BDK team is the BDK CLI tool that we're going to talk about today. So why the BDK CLI tool? The BDK CLI tool is a playground, it's a command line application that helps you to be able to interact with APIs that have been exposed by the other BDK core libraries. And then it also helps you to be able to test out your wallet flows when you are developing wallet. And then it's also a good learning tool for mini-script policies, for descriptors, as well as PSBTs. So how can you install the BDK CLI tool? The BDK CLI tool is developed in Rust. So for you to be able to install it, you need to have Rust installed on your system so that you can be able to use Cargo. So the first place for you to install BDK CLI is from the source. So from the source means from the repository. So I'm just going to go to BDK repository. Once you visit the BDK repository, you can be able to put the code base here. And then once you put the code base, you can be able to see, follow the instruction, which states that you just need to change CD into where you have put the code base to. Then you can run the cargo install command. You specify the path, which is assumed to be the current path where you have put in the code, clone the code base to, and then you pass in the features flag, which you can then list out the features that you want to install. Once that installation is complete, you can run BDK CLI help command to be sure that the installation completed successfully. The second way for you to install BDK CLI is from crate.io registry. So you can just open your terminal and be able to just call cargo install. You state the BDK CLI, and then you pass the features flag, and then accompanying that with the list of features that you want to install. So the BDK CLI tool currently have these features. One of it is the first one I will talk about is the repo. Repo means read, evaluate, print loop, which helps you to be able to establish a terminal session that you can be able to just type in the command and then the sub command for it to evaluate that and give you a response instead of typing out the full BDK CLI command followed by the params. So during the demo session, we are going to touch on the repo repo feature. We also have the SQLite feature, which is a database that helps you to be able to save some of your wallet related information. So all your wallet data, public data will be saved in the SQLite, and it's also set as a default feature. alongside the repo feature. Both of them are set as default features, which means during installation, you don't necessarily need to specify repo and SQLite. They are compiled by default. Then we have the CBF feature. CBF means compact block filter, and it is built upon the BDK library. The BDK library extends the Koto library, which is an implementation of BIP 157 and 158 that defines how light clients can be able to interact with blockchain, connect to nodes, and be able to pull transaction information in a private way. You can visit the BDK Koto, go to the BDK repository, like I said earlier, and then you can be able to visit the Koto. So this is the Koto, BDK Koto. So you can be able to visit the repository to learn more about BDK Koto. Yeah, and then we also have the Electrum. Electrum is built on BDK Electrum library. It's a client that helps, it's a server client that helps to index the entire blockchain and be able to allow us to be able to pull that information from there. And then you also have the Explorer, which is built on BDK Explorer library. We also have the RPC client, which is built on BDK Bitcoin DRPC library, which is just a local Bitcoin node that you can be able to set up, and then it will establish a connection. We can be able to send RPC commands from there. So we obtain that information in a way that our wallet API understands. Then you also have the compiler feature, which helps you to be able to compile mini-script policies, set policy, spending policies on your descriptors that we can be able to use to create a wallet. So in the next session, we are going to do a live demo using the BDK-CLI tool. We'll be covering keys, we'll be looking at ministry policies, and then we'll do some wallet operations. This is going to be our demo flow. We'll first of all do the installation of the tool. We'll look at the help command. Then we'll look at how to generate keys, and we can be able, from there, we'll use the compiler feature to compile some policies. Then we'll be able to create some descriptors that will be used in generating generating a wallet. From that wallet, we'll create and perform a transaction. And while we do that, we are going to use the repo feature. So I'm going to switch to my terminal here quickly. And then I'm going to, the first item is the installation. So how can you install BDK-CLI tool? So I will just say cargo install. Let me increase my font. Cargo install BDK-CLI. And then I will pass the features flag. And then the list of features. Let's say I want to install the RPC, the compiler, the Explorer feature, and a host of other features that will be available. So because I'm going to do a demo and it's going to touch on a lot of features, I'm just going to run all features flag, and then we wait for that to complete. Because I've already installed the BDK-CLI tool, it's not going to take time for it to run the installation. So you can see that it has ignored because the latest version, which is version 1.0, is already installed. So there is nothing to install again. So when you do an installation, you can always check BDK-CLI help to see that it has actually installed. So when you get a feedback, you know that the tool is compiled correctly. So this shows you little information about the BDK. The tool is a CLI wallet application. It's being powered by BDK APIs, like I said earlier. It also contains the usage information, which you enter by typing bdk-cli, followed by the options. Options are those parameters that are not necessarily required because their default values have been set, and then the command that you want to run. So we have available commands are the wallet, the key, the compile, and the repo. So you can be able to run any of the commands. And then for the options, you have the network, the data directly. You can specify that with the dash, the short form or the long form. The short form is -n, and the long form is dash network. And then you specified the network. Though we have the default values here for the network is set to testnet, and then for the data directly is set to your home, then dot bdk-bitcoin. Yes, so we are sure that the tool installed correctly. So the next item on our demo is going to be the help command. So how can you be able to get help in using any of these commands? So assuming that I'm interested in the BDK key command, so I can say key and then I will type help. So this is going to give me information about the key command. It's a top level command. So the usage is how I can be able to run the command. So I will start with the bdk-cli, and then that will be followed by the keyword, and then the command. So these are the available sub commands that are available for the key command. So you have the generate, which is used to generate master extended key, and that generates alongside mnemonic phrases. You also have the restore subcommand that helps you to be able to restore a master extended key from a mnemonic backup. And then you have the derive, which helps to derive the child key from a master extended key. Yeah, so assuming that I wanted to also know about, there are some options that the generate subcommand also have, and I don't know them. So I can just type bdk-cli key generate dash help, and then it's going to print out information about the generate command. It will first of all tell me about the command, and then it will show me how to use it, which is bdk-cli, the key, top level command, the generate sub command, and then the options available for me to pass into that. So the options here are the entropy and the password. They are optional because we have default values that have been set for them. So the entropy, the default value is set to 12. So that is how you are able to obtain help information. This is across the key, the wallet, the repo, the compiler functions, top level commands. That's how you can be able to obtain help information. So the next item on our demo is going to be the keys. So we are going to quickly just learn how to generate a key and then save that key and then be able to use the key. So like I said, I'm going to say BDK. I will just land shared above BDK-cli. Then I will say key and now type generate. If I wanted to specify the entropy, which is the short form -e for dash entropy, I could say -e, and then I can specify the number of key phrases seed phrases that I want. So if I desire 24, I will just enter 24. So it could either be 12 or 24, but 12 is set as the default. So if I hit enter, it's going to generate the key fingerprint. It's also going to return the 24 word phrases, as well as the extended master key that has been generated. Because I'm going to use this key in the next item, which we are going to use in the compiler and the policies, I'm going to save this key. I will generate it to a specific network and then save it in in a variable in our terminal session so that we can be able to use it. So I will just say demo xpref, and then I will set that to the outcome of the above command. So I will say bdk CLI, and then I'm going to specify the network. So I want to have the signet, use the signet network. Recall that this is the short form of dash network. So I'll specify signet network, and then I'm going to pass in the key level top level command, and then I will say generate, and then I will pass in the entropy value, which is 12. So I'm going to use JQ to be able to pick the output of the xpref that has been generated. So you can see that this is xpref here. So I'm going to say this is xpref value that I'm interested in. So I can just be able to set my terminal session here using the declare command in combination with grep2, and I can say demo underscore xpref, and then this will print out the value that has been saved in the demo xpref in the terminal session. Yeah, so this is how you generate keys, but we're also going to use the derive. We want to be able to derive an extended public key from this master private key. So we're going to use the derive. So the derive function, you can see it up here. It states that you can be able to derive a child key from master key. So we want to be able to generate an extended public key from the master extended key. So how you can do that, we are going to run bdk-cli dash network, which is signet, then we'll pass in the key, and then we'll pass in the derive. The derive also contains some params. So we have the xpref value that you want to use. I recall that we saved that in the demo underscore xpref variable, and then we'll pass in the path. We'll pass in the path variable. So I'm just going to share. I'm just going to share what the path represents. So I will tap back quickly into the editor to be able to share what the path represents. So most often you see, so this key is being generated with, so the key is being generated using BIP32. So it defines the standard and the format for hierarchical derivation wallet, which is the standard in the industry. So let me quickly, if I quickly search for HD wallets, so if I go to Bitcoin/BIP and I open BIP32, quickly I can be able to see what the BIP is about, which is hierarchical deterministic wallet. So you can be able to see, but we are interested in the derivation part. So you can see the entropy that will pass to generate a master key. So you have the master node, which is represented by M. That indicates the root key at depth 0. Then you have the wallet accounts. So this could be, which is the purpose. So this could be BIP 84, 86, and all that stuff. And then the next one is the chain type. So this could be mainnet or test network. In this case, we are going to use test network, and then you can be able to indicate the depth of the addresses that you want to be able to generate from. So I'm going to go back to our editor. I'm going to say I have this M, and then the key type that I want to be able to generate is 86. Let me quickly just turn off this distraction. 86, and then I'm going to harden the key. This is enabled. How do I disable this? So extension, copilot, disable. Yeah, so I'm going to have the first. I recall that I said this is the master node key. You have the type of key that we are interested in, which is taproot, and then that is hardened, and then you have the purpose. I mean the key type, the coin type rather. So you have either you have 0 for Bitcoin mainnet, or you have 1 for the test network, and then the next item I have is 0, which indicates the account type, and then you have under the account type we are taking the first account type, and then we have the child, which is index 0. So that under index 0 we have this indicates whether you want to be able to generate external addresses or change addresses. So external addresses is often the first one, which is 0, or the change addresses, which is 1. But in this case we are interested in generating the external addresses. So this is the part that we want to use. So I'm just going to copy this guy into copy this, and then I will come back to our terminal, and then I will paste it as our parts that we are going to use. I have double quotes here, so let me remove one of the quotes. Yeah, so I will hit enter, and then you can see that it's generated the xpop key. I derived the xpop key for us. So this is the xpop key value. You can see the derivation part here represented. Because we might likely want to use this, so I'm going to save this particular key in a variable, the xpop key. So I'm going to save it as demo underscore xpop. I will set it to the outcome of the above command. So I'm just going to copy this command. And then I will paste it here. And then I will pipe it to, I will use JQ and then be able to pick the xpop value from the output. So okay, I think that was let's try that again. I think okay, so this is dash n. So this is this. Let me see if I close this well. So 84 harden, the coin type harden this, and then we close it here, and then we pipe it. So let me pipe it again. So I will now pass in the JQR, the xpop error near the pipe value. So this is bdk-cli xpriv dash pipe. I seem to be lost a little bit here. Yeah, so I'm going to actually doesn't seem to get okay. Oh, so the issue was because we did not indicate that this is going to generate a variable from the beginning. So I'll hit enter, and then I will now search using my declare, and then I will say grep dash I, and then I will search for demo underscore xpop. Yeah, so that has been saved into the terminal session. So you can see that the value corresponds to what was printed here earlier. This is the export key that has been saved. So we have been able to derive the key, and we want to be able to use that in a compile to be able to compile our Miniscript policy into an external descriptor that we can use to generate an address. So I'm quickly just going to talk about policies a little bit. So there is an interesting learning source here about Miniscript policies. You can visit this website called bitcoin.sipa.be/Miniscript. So you can learn about Miniscript. So if I come here and I'm interested in a single key policy, so this is how it's represented: policy, and then PK, and then I'll pass in the key that I want to be able to use to derive that policy. So you can see that this is the name, requires a key name. So to sign, so name can be a string up to 16 characters. So these are just information about the policy. But what I want to point out here is that this policy, for a single key policy, what it means is that you only need a single signature to be able to sign funds that will be sent to a wallet that is derived from addresses that will be derived from the descriptor that will be generated from the compiled policy. So you also have things like one of two. So this is how one of two keys. So you see that this policy indicates that either key 1 or key 2 can sign a transaction, and it will either of any of the keys can be able to sign a transaction and be able to lock funds that will be sent to addresses that will be generated from the descriptor that this policy can compile into. You also have things like 2 of 3. So this is how you can represent that. 3 of 3. So you can have initially you have 3 keys that are required. So you could that could be a combination of this key 1, key 2, and key 3. Or after 90 days, you have 2 of the keys are required. So in our example, we are going to just, I also have some other examples which I pasted here. Here, this is a 2 of 3 multi-sig key type policy that you can be able to compile into a descriptor. So here you see that the threshold signatures that are required are 2 out of the possible 3 keys. So key 1, key 2, and key 3. So you have two signatures can be able to sign to unlock funds that will be sent to an address generated from this output descriptor. Here we have one, a single key. So we said or. So we state the next condition, so which means that if funds are locked into this particular key, you can have a signature will be required to unlock these funds, or after block 144, no signature is required to be able to unlock funds. So we are going to use this as our example. In our example, to be able to compile this policy into an output descriptor and see how that is done. So To be able to do that, I'm going to quickly tab back. Remember that we have our export key here being set to this value, so I can just be able to use the compile directly. So recall that we have this, so I'm going to copy this guy from here into our terminal. So I'm going to say, for me to be able to use the compile, I will say bdk-cli. I want to use the record that I was using the Signet network, and then I'm going to say compile. So this is going to compile, and then I will say the type of key. So let me even do dash help so that we can see the available sub commands and options that you can pass. So for you to use the compile, you need to use this bdk-cli. You pass in the top level compile key, and then you have the options, optional command, optional arguments, and then the policy that you want to compile. So we have our policy ready, which is going to be this, whereby a key can sign a transaction or no signature will be required to sign after 144 blocks. So that is our policy here, and then the options that we have are the type of key. So this can be a script hash key type or witness script hash, which are SegWit keys, or script hash embedded in witness script hash keys. So I wanted to share that, so you could be able to say dash dash. So we have dash t, which is the short form of dash dash type, and then I'm fine with the witness script hash type, and then I will paste our key policy, which states we have all of pk of the xpop. Recall that we save our value as demo underscore xpop, and then we have all, when you have order, let's say 100 blocks, 100 blocks, and then we can close our policy with a double quote. So I think we got that right. Yeah, so I want to be able to compile this policy. So I want to be sure that this is closed properly. So this closes this closes this. Yeah, so our policy is complete. So I can hit enter. So you can see that top level script is not safe on some spending part. So what it's saying here is that using this kind of using this script policy is not safe to spend on some parts. So instead of doing that, we can just use a single and remove the second condition that sets the key to that sets that key to be spent after 100 blocks if no signature, even without a signature. So I'm just going to use this x demo pub, and then I'll hit enter, and then you can see that we have generated a descriptor, but what we ended up compiling was just a single key that is required to unlock funds that will be so if we use this descriptor to create a wallet, in that wallet you only need a signature that indicates that the person signing that transaction owes the public key, owes the secret key to the public key that we used here, and you can be able to unlock funds from that. So that is how you are able to compile policies. You can go ahead, you can test out like things like the 2 of 3 multisig here, and then that will be able to generate that for you as well. So the next part of our demo, we are going to look at descriptors. We want to be able to generate descriptors. So recall that we have a descriptor here already, but we don't want to use this descriptor because it's generated from an export, and we cannot be able to, when we derive a wallet from that, we cannot be able to sign. So I'm going to make use of a master key to be able to describe to derive a descriptor from it, and then form a descriptor from it, so that we can be able to use that to be able to sign our transaction. So I'm going to quickly go back to our terminal. So here, a descriptor often take the shape of a function, and then you have the path, the descriptor path, and then you have let me just quickly just cancel this. Don't save. I don't like. So let me just do this. So we have a descriptor. Let me expand. So you have a descriptor type, which could be a function. In this case, we are using taproot descriptors. Then we can have the key, and then we can have the path. The paths, the descriptor paths. So in this case, we can have it as 86 hardened, and then we can have 86 hardened means we are interested in taproot descriptors, and then we can have the coin type, which is we are using SegWit, which is a test coin, and then we can have zero harden, which indicates that we are taking the first account type, and then we can have the first zero, which indicates that we want to generate an external descriptor that can be able to receive addresses, generate addresses for us to receive, to share and receive funds. So if I generate this, I'm going to just quickly tap back and copy the value of our xpref. So I will just use the terminal to echo our xpref demo underscore xpref. So this is our master key that we generated earlier. So I'm going to use it. Let me quickly change this from this to this. So I'm going to use this key to be able to say, okay, I want to generate an external descriptor. So this is going to be the function is tr, which indicates it's a taproot key. Then I'll paste in my key. Then the next item is going to be the path that follows. So I'm going to just copy this guy from here as the path, and then I'll paste it here. So this is my external descriptor. Let me quickly reduce this a little bit so that I can see very well. So I can also copy this and then paste, and then be able to use this as internal descriptor, but I need to change from 0 to 1 at the last, which is the last page, which indicates external addresses or internal addresses, which these are change addresses. So this is used to be for external addresses to receive funds, external addresses, while this is change addresses. Yeah, so I'm going to save these values in our terminal so that we can be able to make use of them to be able to use them as our descriptors to when we want to generate a wallet. So I'm going to say external, I will say demo underscore external demo signet. I want to include demo sig external descriptor. I will set it to this value. and then I will say demo signet internal descriptor, and then I will also copy the second value. So this is the second value. I will copy that and then I will paste it here, and then I will save. Yeah, so having saved those in a variable, these are going to serve as our descriptors when we want to create a wallet. So the next item on our demo flow list is wallet. So we are going to learn how to create wallet, and then we can do that. So I'll quickly just I'll quickly just say so I'm going to say let me quickly just put these descriptor names into our this, so that we can be able to search it whenever we need it. So I'll clear the screen, and then I will say bdk-cli wallet. I want to get help. What are the available commands and options when you want to generate a wallet? Yeah, so this has brought the wallet information wallet top level command. For me, it also shows me information about wallet, the top level command, and then how I can be able to use the wallet top level command. So I will say bdk-cli. So you have the top level wallet command, followed by the options. So the next thing that is required is the client type. So this can be RPC, this can be Explorer, this can be Electrum, this can be CBF client types. Those are the ones we have available. Then the database type, we only have SQLite enabled for now. And then you can specify the URL of the client that you supplied here. If you're using RPC client, then you need to supply the cookie, which is optional, and then you can have the command, the sub command. So I will quickly just run you through these sub commands, and then we can go ahead and create our wallet. So I will say this is the first sub command is the full scan. So what this does is going to go through your wallet, generate a set of addresses, or what we call script pop keys, then scan the blockchain for those. So it will derive those addresses at derivation indexes start from 0. So when it searches the blockchain, if it finds any transaction information related to that particular transaction data related to that particular address or script pop key, to fetch that data and then save it. So we have a label we set. We have a set in the code base that it should use a wallet gap of 20, which means that if it generates 20 addresses and there are no information on the blockchain containing that, it will stop. The sync functions the same way, but what it does is it starts from the last known sync address information that is saved in the wallet. And then you also have the broadcast subcommand that helps you to be able to broadcast PSBT to the blockchain. So you can use any of the clients available that we are going to use, in that case, to broadcast our transaction. Then you have the new address, which generates an external address that you can share to receive funds. Then you have the unused address, which returns the first external unused address. We have the unspent. So this indicates the available balance that you can be able to spend. UTXOs that you can be able to spend. This returns the list of transactions, whether they have been sent to your wallet, to addresses that are being controlled by your wallet, or whether you sent out some transactions, you perform some transactions that sent out UTXOs to an external address. So they will all be listed under this transaction subcommand. Then you have balance. This indicates the balance of the wallet. We have the create transaction command that is used to create a transaction. In this case is PSBT, partially signed Bitcoin transaction type. You have the bump fee sub command that helps you to be able to increase the fee of a transaction if the fee is too low, but it has to be have this replaced by fee RBF feature enabled, and we have that enabled by default in the tool. Then we have the policies, which we return the spending policies of the descriptor that was used in deriving the wallet. This will return the public descriptor information. You can use this to sign your PSBT and finalize it. You can use this to extract a raw transaction from a PSBT. You can use this to try to finalize a PSBT, and that will return true or false if that is possible. While the combine PSBT subcommand attempts to combine multiple PSBTs into a single PSBT. So we are mostly going to touch most of these sub-level commands. So since we have our required data, I'm going to generate a wallet. So I will say I want to use the signet. The top level command is wallet, and then I want to pass in the wallet name. In this case, I want to say CLI signet demo wallet. That's a very long name anyway. And then I can pass in the -e flag, which is the external descriptor. So I think we save that as demo sig external demo sig external descriptor. Yeah. Then we have the -i, which is the internal descriptor that I want to use. So this is demo sig internal descriptor, and then we want to use the client type that we want to use is the Explorer. So you can use Electrum here. You can make use of the RPC or the BitCBF type, and then I'm going to pass in the URL of the server that we want to use. In this case, I want to use the mempool.space Explorer client, which is /signet/API, and then I will pass the database type, which is the SQLite in this case, and then I want to create the wallet and return the policies on that wallet. So our wallet has been created. You can see it returned the policies information. Remember that policies, this information shows you the spending condition on that wallet that is created. So you can be able to see that the type of signature that will be required to sign signatures is a small signature. To sign your transaction is a small signature type. You can see that the fingerprint for the external and the internal descriptors are the same. So this shows you that this was generated from the same root key. And then you can see that the type contribution, there are no conditions except required for you to supply a signature to sign that transaction, and then it will be complete. You have the ID, the satisfaction. So you can actually just go to the docs to be able to look at these policies and what each of these here means. So having generated a wallet, I want to use a single stone to be able to key to base. So I will use the repo feature to be able to carry out a transaction. So I'm just going to say tap back to the last command that we had. So I'm going to say this is a repo. Most of these are not required. Things like the descriptors are not necessarily required for me to start the repo session, but I'm going to allow them to be there because I want to be able to create and sign a transaction. So I can say this I will replace the wallet top level command with repo, and then I'll pass in the wallet that I want to use, which is in this case is CLI Signet Demo Wallet. And then I passed in the external and internal descriptors. I will pass in the client type, which is Explorer, the address of the client type, the client that I'm using, which is mempool space Signet, and then I will say SQLite, and then this database that we're using, and then this opens up a session, a terminal session, where I can be able to type in my transaction command. So the first one that I want to do, I want to be able to generate an address. So I will say wallet new address. So this is going to return a signet address for me. So I'm just going to copy this quickly, and then I will use a faucet. In this case, I'm using this faucet here to fund the address. Signet 25 faucet to fund that address. So it's doing verification. Once that verification is done, I will supply the address since my network is not too good. Yeah, so I can paste in my address here, verify again, and then I will click to receive. So I can be able to see that details of that transaction on the mempool.space explorer. So you can see that that transaction hasn't been confirmed yet. So I'm going to tap back into our terminal. So let me just change that quickly. I will say, since I have not synced the wallet, if I do wallet balance, you can see that everything is 00. Nothing is confirmed yet. So I will sync the wallet now. I will say wallet, because I'm doing the first syncing, I will do the full scanning. So this is going to scan the entire blockchain. That has completed. I can do my wallet balance once more to see if that has been seen in the mempool yet. It doesn't seem yet. So back to our Explorer, you can see that it is still pending. Nothing has been reflected here yet, but you can see that the type of transaction is paid to a taproot. While that is going on, that confirmation is going on, there's some couple of commands that I told you that we can be able to run. So we can be able to check if there are any unused addresses. We can be able to see if there are any UTXOs are available for us to be able to spend. So if I do transactions, I will say wallet transactions. This returns empty. Wallet spend. This also returns empty. As time goes on, once that transaction that we are receiving comes back, we can be able to do that. We can even check. We checked the policies before. We can check the public descriptor of the wallet. We can also be able to check any unused address. So I can just come here and say unused address, wallet, unused underscore address. So you can see that because nothing has been received yet, that is the address. If you see earlier, this is the address that we are trying to receive funds from, but because those funds have not arrived yet, it is showing that it's the first unused address that you can see in our wallet. So I'm quickly going to change back to this to see if anything has dropped yet. Nothing has been confirmed yet. So I will say wallet. I will still sync to see if there's anything. So I'll say wallet balance. Nothing has been confirmed yet. So while that is while we are waiting for confirmation, I will quickly just take you to some of this. So I have the balance struct open here in the code base, where I can be able to show you balance that we are seeing there. So you can see that when we have immature, it means that this is showing us that those coins are coming from Coinbase transaction, and those coins are yet to mature. So that's the category you see immature here, and then for trusted pending, it shows us that this is the amount that have been generated by our wallet but hasn't been confirmed. Uh, I hope I didn't change that. Oh, yeah, so I mistakenly changed that. So this is unconfirmed UTXOs that have been generated by our wallet. So they have been seen, but they have not yet been confirmed. Then for untrusted pending, you have those unconfirmed UTXOs that you are going to receive from an external wallet. So in this case, we are receiving funds from an external wallet, so they should appear under the untrusted pending amount. And then for those confirmed, there are those amounts of satoshis that have been received and or we have in our wallet that we can be able to spend. So we also still refresh our Explorer to see if there's anything yet. I will do wallet sync one more time. I will then check the balance to see if anything has changed. So while we wait for that, I encourage you can go through. So this is BDK underscore wallet code base. You can be able to like look at the transaction builder that has been built, that was used in the tool. You can explore the code base to be able to check to see how these APIs are implemented. I'm going to, what else should I talk about? Let me look at public descriptor, so I can be able to say wallet public underscore descriptor. So you can see that this shows the external keychain, external descriptor rather. So you can see the path, you can be able to see the paths, and then this is for internal descriptor. You can be able to see the descriptor, they look similar. So you can see this is 0 for external and 1 for internal. I'm going to go back to mempool.space to see if there is a change yet. You have not received coins. Yeah, so other than that, I can you can also be able to, like I said earlier, you can be able to take a look at how most of these are implemented. There are examples that you could be able to run. There are tests, you can go through the tests to be able to see this is PSBT and the rest of them, that any of the APIs that you don't know how is derived. No luck yet. We have not been able to receive that. There is nothing confirmed yet. Sometimes this can be, yeah, so using a faucet. So let's be a little bit patient. Wallet sync one more time. Wallet balance. Nothing has been seen yet. So I'm quickly just going to pause this for a few minutes to see that if it has been confirmed, then we can resume session. So after a short while, I can see that the value that has been sent has been reflected here in the pending. So I'm going to tap back to our wallet, and then we can do a wallet sync one more time. When we do the wallet sync, that has completed, I can be able to do a wallet balance to check the balance. Also recall that when we check the balance, we see that it has reflected as untrusted pending, which means it's the value, this value has this UTXO was is coming from an external wallet, and it has not yet been confirmed. So we can just wait, hopeful that this will not take any much time for it to be confirmed. Yeah, this hasn't been confirmed yet, but yeah, so we can also do another sync to check. Then we can do wallet balance. That hasn't been confirmed yet, but we can be able to see. I think this should have been registered under the transactions. You can see that this is the transaction that is sending some coins to us. So you can see that it has a lot of outputs. So this single transaction contains, so you can see it has even more 1,912 outputs remaining. We can also do wallet unspent to be able to see if there's anything there. So you can see that it returned the chain position, but it's unconfirmed yet, and this is the last seen. So you can see the timestamp when this was seen. You can see the derivation index is 0. You can see whether it's spent is false. We did not it did not originate from our wallet. So you have the key chain. Type is external key chain. You have the out points. Remember that the out point is the transaction ID and the output index. So this is the ID of the transaction, and this is the output index. And then you can see that the output, we have the script pub key. This script pub key is derived from the address that our wallet generated. So it's our script. And then you can see the amount of Satoshi that is pending. So we can do wallet sync one more time to see if that has been confirmed. So we can say wallet balance if that has changed. It hasn't yet been confirmed. But you can be able to look up this chain information from the code base, like I said. So this can actually just give you an idea of what index. So if you are going to spend, if you are writing an application, you know that this can return, use this out point. You can be able to use this out point when you want to spend. So I'm going to do wallet sync one more time. And then I will do a balance. It's still yet unconfirmed. It should be confirmed any moment from now. So you can see that even on the Explorer, you have 00 and it's still showing unconfirmed. So we just wait a little bit for it to be confirmed. This is one of the fears of doing a live demo, because anything can decide to fail. So this is taking longer than usual. Yeah, it seems we have a confirmation. So we have wallet sync one more time. That's a sync, so we can do wallet balance, and yeah, we now have our coins. So the transaction is now confirmed. So since our transaction is confirmed, we can now be able to construct a transaction and be able to spend the coins. So we are going to say I'm going to go to the faucet that we receive, and then we can be able to get an address where we can recycle the coins back, send the coins back. So I'm going to copy the taproot address. So I'll come back and say wallet create on the tx. I want to send all back, all the coins back to the faucet, and then I will specify --2, and then I'll paste in the address that I want to send. Because I'm sending everything back, I'll just put the value of 0. So this has created a partially signed Bitcoin transaction. So I'm just going to copy this, and then I will attempt to sign. So I will say wallet, I want to sign this transaction. Then I'm going to pass in the value of the PSBT that we want to sign. So you can see that signing was successful. So you have finalized is set to true, and this is the value of the signed PSBT output. So I'm going to copy this, and then I'll be able to say wallet broadcast, and then I will say I want to broadcast a PSBT, and then I'll paste in the signed PSBT. So if I hit enter, you can see that it has broadcasted the transaction. So I can be able to copy this and search on the Explorer. So I can just quickly come here, and then I will paste it. The Explorer, you can see that it's just been seen. It's not yet confirmed. You can see the fee rate, which is the sats per VByte. You can see that it has RBF enabled, is Segwit transaction. It has not yet been confirmed. So I can come back here and do a wallet sync, and then we can check our balance, wallet balance. You can see that the coins have left our, everything was spent because I did a spent all, and we have back to 0. So I'm going to exit the repo, and then I will just type in so assuming that I was doing, they are both using the full commands, I don't necessarily need to pass in this since we have already signed our transaction. I can just replace this with wallet. So for me to be able to check the same balance that I was checking above, I could just type this full command, and then to sync, I will also have to type sync here to see if the transaction that was broadcasted has been added to the mempool yet. So since those coins have already left, you can be able to track. I think it was pointing is the next, it will be included in the next block that will be mine on the Signet network. Yeah, so back to this. So we have been able to, in our demo, we have been able to do the installation of the bdk-cli tool. We looked at the command, help command. We were able to generate keys using the key top level command. We're able to compile a policy into an output descriptor. We're able to create internal and external descriptor so that we could be able to generate a wallet from there. We were able to generate a wallet. We receive funds from a faucet, and then we were able to construct a transaction and send back. While doing that, we're able to look at things like the balance, the unspent, and a host of others. So the next steps is for you to, depending on the purpose you are using the tool, you can go ahead and play with the tool. You can be able to build things using the BDK APIs. Use this tool to be able to test it. You can be able to join the community. I will share that in the next slide. And then your contributions are also welcome to make to the BDK suite of libraries. Here are some of the resources you need. You can join the Discord community. If you cannot see this, you can be able to visit the BDK repository to be able to see. So you can just come to BDK repository. You can see where you can be able to join. Just click on this link to be able to join the Discord community, where you can be able to contribute, make your contribution, ask questions if you have any question, and generally contribute. If you want to read more about BDK, you can visit the BDK website. It contains a blog session that has some technical articles that you can also read, as well as the book of BDK, which is a documentation that talks about all the libraries in the BDK and how you can be able to integrate them into your app. Thank you for joining me on this session. I hope you are able to learn one or two things that will be useful. Thank you, and bye for now.